Thank you very much. Thank you very much, Andrea, and good morning, everybody. Let me go to some presentation mode here. There. Okay, I'm the first one among the group presenters, and like Andrea said, this is an easy presentation on one hand and a very difficult one on the other hand. Easy because I'm going to read off lots of people, topics, groups, and so on off the slides, and difficult because it's going to be hard to keep you interested for 45 minutes. So I apologize in advance for my inadequacy in doing so, and I'll try and do my best. Well, I'll start out with an easy one. It's a bunch of happy faces, mostly. This is the telecommunications group with faces and names. In the next upcoming slides, you only see the faces. It's sort of a game. You have to memorize all the names, and then you'll see just the faces. I'm kidding, but you know, it's true. There's only faces later on. Anyway, I have a list here of the same 27 people that you saw on the first slide. Why 27 people? Because those are the permanent teaching staff. By permanent teaching staff, I mean full professor, associate professors, and assistant professors, that we call researchers here. We could have gone on to assegnisti, postdocs, and so on, but as you will see, it's a large, large number, so we decided to stop to these 27. All the group members belong to a sort of ministry taxonomy that is the macro group 09F, that is communications engineering and electromagnetic fields. And the subgroup is what I'm talking about today is telecommunications. I'm going to call it telecom. It's interesting to see that traditionally the telecommunications groups is close to the electromagnetics group. This is more out of tradition, I would say, but there is a reason for that, because when you transmit information, you typically encode it over some form of electromagnetic field, light, radio waves, current, voltage, and so on. And therefore, certainly there is a contiguity there. But I should say that in later times, in more recent times, the telecommunications group has developed very substantial contiguity also with information science and computer science as well. Some group statistics. The group has 27 permanent teaching staff, like I said, which makes up for a big part of the department, 30% about of it. 7% is female of the telecommunication group, and 20%, of course, is male, which is not so bad as for gender equality in engineering. I think it's pretty much of a record. I should investigate on that. Anyway, other members as of the end of 2011 is 18 assegnisti, meaning research assistants and postdocs, and a large number of PhD students, whom I hope are here today to see this presentation. So the total is 86, a very large number for the telecom group. I think it's always good to remember where we come from. So on the first row here, you'll see appearing some of our founding fathers. Actually, these are the founding fathers of the telecom group. Very capable people, many of them very successful also outside of the group. Valentino Castellani was mentioned before. He was mayor of the city of Turin for 8 years, and then he was also, I guess, the head of the organization committee for the Winter Olympics in Torino. And in the second row, I've put younger people who were at some point permanent teaching staff group members, but then left and went out to pursue very successful academic careers, mostly abroad in the US, I guess in Australia and so on. So including these people, this is the sort of the larger telecom group, because we still have very strong ties with these people as well. Now, this slide is intentionally left blank at the beginning because I wanted to convey a sense of void and loss that is related to one of our dearest colleagues passing away far too prematurely about 1.5 years ago. And of course, I'm talking about Professor Fabio Neri. I should say that this void isn't filling up at all. In fact, I personally feel it more strongly now than 1 year ago. Fabio was a powerful force in the group. He was an excellent scientist, and he was a great organizer and motivator of people. He was always pulling together people from different groups to form new cooperative projects, towards which he worked absolutely indefatigably. He, in fact, led many large projects, Italian and European, and he was held in high esteem worldwide. Fabio was also a friend to many of us. And Fabio will always be, in my opinion, an example and inspiration to those who knew him throughout the end of our respective careers. And I would like to thank Fabio for what he did for us. So let me move on to the more technical part of this presentation. Traditionally, the telecom group encompasses three main topical areas: transmission, signal processing, and networking. Topical areas roughly correspond to subgroups within the telecom group, but this paradigm is not rigid, and typically there are many cooperative research projects that include TLC group, telecom group members from different topical areas. And besides, we're trying to push interdisciplinarity as best as we can. So let me start with the signal processing group or topical area. The signal processing group performs research in the theory and application of modern information handling systems. It addresses the theoretical foundations and practical implementations related to three key drivers. First driver is certainly visual content, very important today. Then location, where we are, how we can find out where we are. And communication, well, in the sense of what we communicate to the others. These three key aspects are the core research areas of the individual subgroups of the signal processing group listed in the following. So for video, there are people who deal with image and video processing. For location, there are people who deal with navigation. And for communications, there are people who study non-stationary signals and systems. This is more theoretical area, and communications in general. And I'm going to go over projects now in the following projects regarding these various topics. But before doing that, what are the theoretical tools that this group exploits? First of all, various tools, since I'm not going to read off all the things. You know, the slides are going to be available to everyone, so I'll try to be quick where it is possible to be. Tools in signal modeling, tools in signal representations, transforms, and so on. Tools in signal analysis, especially statistical signal processing and detection estimation theory, and so on. System theory, deterministic and stochastic differential equations, a very difficult area, this one. Prototyping in software, DSP implementations, and so on. And then also experimental test beds. Now let's move on to a list of projects. And the first one I'm going to talk about is distributed multimedia communications. And the driver here is the following. Multimedia contents have to be compressed and delivered to users with high quality of experience. You don't want video to be choppy, audio to be inaudible, and things like that, I guess. And the person who's dealing with this is Enrico Maglio in this case, but I'm not going to mention all the names. You'll see the faces, like I said, and then if you want to know who they are, you go back to the first slide. So video broadcasting and peer-to-peer streaming using rateless codes and network coding. This is a specific investigation topic, and you see like an example of a peer-to-peer network there. And scalable and multiple description for image video coding. And visual search for image retrieval. This is very interesting. You take a shot of a certain location, and then you hope that your smartphone is going to tell you something about it by recognizing where you are. There is a project here in which all this is included in collaboration with Telecom Italia. Compression and compressed sensing. Media content has a huge size and must be represented using a compact format. This is a big driver for it. Again, same person as before. Image compression for space applications, compressed sensing and signal acquisition beyond Shannon. You know, interesting new techniques. I guess in cooperation with the European Research Council. And GPU implementation of image video coders. Again, there are projects. You'll see the project mentioned at the bottom of each slide. Then we have people investigating satellite navigation and positioning receivers. And here, the driver is the design of acquisition and tracking architectures for new GPS and Galileo signals, multi-system and hybrid receivers. Some of the people involved. And here we have researching new algorithms tailored to the new modulations and signals, fully software implementations, and advanced signal processing algorithms for multi-path robustness, high sensitivity for indoor, urban, and harsh environments. Of course, you want to be able to find out where you are also in these environments. RF interference mitigation and anti-spoofing, anti-cheating, anti-confounding you. Hybridization with inertial system and communication systems. And these are, again, this is again a list of the several projects in which this research is included. ESA, of course, is a European Space Agency. Again, on satellite navigation and positioning application, we have a driver as the study of satellite navigation technologies enabling new applications of positioning services. This is closer to the user, closer to the end utilizer. Mass market, professional, and scientific. Again, the people involved. And here we have peer-to-peer and cooperative positioning, whereby maybe you interrogate some other people or devices around you. Reflectometry, ionosphere sounding and modeling, and positioning based on signals of opportunity. Whatever signal you pick up, you try and use it to find out where you are, I guess. And here are again, is again the list of the several projects in which this research is included. Then we have a fairly theoretical, but also with real-world application topic, non-stationary signals and systems. Real-world signals are inherently non-stationary. We sometimes make the assumption that random processes are stationary, their statistical features remain the same over time. That's actually an approximation, typically, and in many cases this is not at all true. And so you need time frequency analysis of dynamical systems. You have to bring time into the picture. You can't assume stationarity. Statistical signal processing for atomic timing, because it turns out that some of the noise processes taking place in atomic clocks are non-stationary intrinsically. And signal processing for atrial fibrillation. And this is interesting because it's one of those instances in which signal theory couples with something that has to do with medicine, with biology. And it turns out that some of the electrical signals coming from the heart of people who have arrhythmia are random processes of non-stationary type, and you really have to use sophisticated tools in order to study them and hopefully make diagnosis possible. And again, here are a few projects in which this is included. Then a little bit of an exoteric application and signal processing for quantum communication and cryptography. Study of novel iterative signal processing techniques for improving the performance of quantum communication and quantum cryptography. This is all based on very exotic properties of quantum theory and like entanglement and things like that. And some of the investigated topics are soft decoding for information reconciliations applications, modeling and performance evaluation of quantum communication schemes, and signal processing techniques applied to quantum cryptography schemes based on biphoton states. By the way, it turns out that if you use these exotic properties, you can make transmission of information basically intrinsically secure. It's sort of an unbreakable code on a fundamental level. And interesting collaboration with INRIM, Moscow, Lomonosov State University, and UCS. The signal processing group has 3 laboratories. One is an image and video processing laboratory. I'm not going to go over the fine prints here. Another big laboratory is the navigation lab, jointly with the Istituto Superiore Mario Boella, where they do many things, for instance, digital simulator for simulation of current and future signals of GPS, Galileo, and GLONASS, and so on. And finally, NAVIS Research Lab. This is actually located elsewhere, the Hanoi University of Technology in Vietnam. It's, I guess, a cooperative enterprise. So let me move on to the second subgroup, big subgroup of the telecom group, the transmission group. And the main topics addressed by this group are Well, first of all, wireless and satellite transmission. Then wireline, where you have actually a piece of wire of some form. Optical transmission, optical fiber, and ADSL, copper. Then communications and coding theory, and then information theory and cryptography at a theoretical and mathematical level. What is the mission of the transmission group? Well, it is to transmit information, more information, faster, farther, everywhere, more reliably, with less delay, in a more mobile fashion, more flexibly, and very important today, these days, in a green fashion, with less energy consumption at a lower cost, of course. The transmission group also has a theoretical toolkit that is based on information theory, modulation and detection theory, communication system analysis and statistical performance evaluation, and then a bunch of techniques that have to do with advanced coding, equalization, and synchronization. Then modeling and simulation is very important in the study of transmission systems, especially to model the physical channels, and then cryptography, of course. Let me move on again towards more focused projects. And the first one is wireless and 4G, LTE, long-term evolution, I guess it means. Meaning the new generation of cellular communications and networks. And these are the people mainly involved in it. A big thing in this realm is MIMO, multiple input, multiple output systems. And here we have some subtopics, line of sight MIMO and dual polarized systems, asymptotic performance analysis based on replica method, interference cancellation for MIMO, and network and device testing measurement systems. This is a more practical item. Also, design of high-speed adaptive coding modulation system with highly variable spectral efficiency from less than 1 bit per second per hertz to a very efficient system with 10 bit per second per hertz, depending, I guess, on environment and so on. One collaboration is with Telecom Italia, testing labs, and another one, important one, is with Ericsson for high-capacity radio links for the backhaul of the wireless system. Wireless cell phones are always with us, all the time. And in fact, one of the outcomes of this latter collaboration is a standard for a serial concatenated convolutional code that is going to be adopted in the next generation of radio link backhaul in Ericsson equipment. Of course, another big important thing is satellite and space systems, with the people involved. And they study satellite and spacecraft tracking, telemetry, and telecommand. They investigate spectrally efficient data transmission, again for telemetry and ranging, but also for, of course, for broadcast and broadcast satellite applications. Channel coding for error correction, also for deep space probes, anti-jamming protection, and of course, international standards update. Important collaborations here is with the European Space Agency, and in fact, an adaptive coding and modulation scheme based on SCCC is currently a standard for near-Earth missions under the standardizing body, the CCSDS. Then there are other collaborations, this one, the Thales Alenia Spazio for near-Earth observation, and again, those are the main investigational topics. I should like to spend 20 seconds on this very important collaboration that took place some time ago with NASA JPL, because some of the turbo codes, error correcting codes designed jointly with NASA JPL are currently employed for the transmission of the rover Curiosity that landed on Mars just recently in August. And the two people involved in that project are shown here, Sergio Benedetto and Guido Montorsi. Sergio Benedetto is an ex-member by now, but I mean, I think it is important that when we have this sort of success that we take pride in it. Cognitive radio. Spectrum resources are scarce, to say the least. And so it may be a good idea that secondary, so-called unlicensed users may exploit the band when primary licensed users are not transmitting. So I am a primary user, so I have a certain band, I'm not using it at this time, and so someone else, well, I'm not using it, makes use of it. And so you really have to analyze things in frequency and again in time to see when this band is available. These are the people investigating this interesting topic with spectrum sensing technique to detect the presence of primary users, and then in software radio that makes use of the available free spectrum when it's available. And this is a collaboration ongoing with CSP. All of us, I guess, take advantage of internet through ADSL at home as of today. So it is important to look for techniques for improving users' bit rate and reduce energy consumption. And so these are some of the topics: vectoring, DSLAM coordination over different users, and impulse noise protection in collaboration, predictably, with Telecom Italia. There are some further investigation topics: sparse, easy channels, compressive sensing techniques. This actually has to do with undersea underwater acoustics. And it's also used for underwater surveillance, so this is a related topic. These two go together, a very interesting research area. And then cryptography, especially elliptic curve algorithms. This is research carried out by Professor Michele Lia. So within the transmission subgroup, there is a structured subgroup, the OptCom group, that deals mainly with optical communications using essentially light, typically not visible light, but infrared light, including myself. The OptCom group has a large laboratory, large and well-equipped laboratory located at the Istituto Superiore Mario Boella, and in fact in collaboration with them. We do several experiments. I'm going to go over them in subsequent slides, so I'll skip this. The lab has top equipment. Let me mention this impressive piece of equipment, real-time scope that has 4 channels at 50 gigasamples per second. That's a pretty impressive piece of electronics, really, not optics in this case. So the kind of research that the OptCom group does is, one thing is on long-haul optical fiber transmission. And a little bit of introduction. In the last 5 years, long-haul optical communications have sort of become radio-like. What do I mean by that? That for 30 years or so, the only used transmission technique in optical fibers was turning on and off the light, like smoke signals, on and off. But in the last 5-6 years, there's been a big shift, and also in optical fiber transmission, there's been a migration towards stuff like that, 16 QEM or even 64 QEM over 2 polarizations. And capacity per fiber has skyrocketed, so that today we're talking of 10,000 gigabit per second per single fiber over multi-thousand kilometer links, and that is commercial. So these are the people involved in long-standing collaboration with Cisco Photonics on exactly this big transition that took place from smoke signals towards more structured things. We've done a lot of research. We've had breakthrough results in optical fiber nonlinearity modeling and record experiments carried out in the lab at the Mario Boella Institute. The OptCom group also deals with free space optical communication, no fiber there. Especially in the realm of intersatellite links, satellite to Earth, and deep space probes. Person involved, Walter Ferrero, and there were 2 initial projects in collaboration with the Agenzia Spaziale Italiana and also the Istituto Mario Boella. And I think this interesting demonstrator was built where there was a telescope shooting a laser beam towards another telescope, which was shooting back another laser beam, and a communication system and pointing mechanisms in order to keep things all aligned. This was an Earth-based demonstrator over a few kilometers, and it was supposed to go up on airplanes and then in space. I guess there's a little bit of problem of funding now, but I'm sure that this is going to be resumed sometime soon. The optical subgroup activities on optical access networks are also very active. 2 main areas of research in the last 5 years. One has to do with plastic optical fibers, especially for in-home now. They're very much considered for in-home installations. In any case, there were 2 STREPs coordinated by this person here, Roberto Gaudino, and in collaboration with ISMB. And now the investigation has shifted to passive optical networks on glass fibers for access, a new research area for the group. We're actually connecting homes to the central office through optical fibers in a tree-like fashion. I'll spend just 2 seconds on this. The current picture of access is thousands of twisted pairs, like incredible bundles like that, and as we know, a few megabit per second. Migration path is hopefully towards some 100 optical fibers, very neatly arranged, hopefully, and up to or beyond 1 gigabit per second per each residential user. And a new EU project coordinated here at Politecnico by Roberto Gaudino is starting right now. It's called Fabulous and investigates this new paradigm. Simulation of telecommunication links. The whole transmission group has been traditionally involved in this. Simulation of transmission system is absolutely necessary to better predict given the system performance. And of course, there was a lot of development of software programs designed to simulate the physical layer of links, including channel models that take into account various impairments for standard and non-standard technologies, using various programming languages. And these are some of the tools that actually came out of these efforts. TOPSIM, the traditional one, Fortran, textual interface for radio system satellite communication. TOPCom++, again on satellite communications, developed for ESA. OPSIM, with graphical user interface for optical systems. And further, there are other tools, more ad hoc tools. And I'm listing here again the tools with the people that were behind them. Actually, TOPSIM, I think that all of the group worked on it at some point. But the real driving force behind it was Mario Pent, an ex-member of the group and founding father of the group. TOPCom++, I guess Guido Montorsi is one of the force behind it. And OPSIM, the optical communication group. And special purpose, these 2 ladies here. So let me move on to the third and last. Let me see how, okay, I'm doing fine with time. The last, but not least, subgroup in the telecom group, that is the networking or telecommunication networks group, TNG. TNG is one of the largest groups in Italy, focusing on telecommunication networks and application topics related. Expertise and activities can be classified according to 4 dimensions: issues, domains, applications, and tools. Now let's go over each one of them. Oh, by the way, if you want to take a look at details, you can go to this URL. Key issues in TLC networks and protocols. Well, characterization is an issue of networks and traffic. You want to know what's going on. Design and control of protocols and networks. And of course, performance evaluation and optimization. Domains in which we want to do this. Wire networks, of course, the internet with photonic, backbone, metro, home. Wireless networks, satellite, cellular, ad hoc, mesh, vehicular, and so on. Routers and switches, the nodes of the networks. And applications, all sorts, but especially video distribution, peer-to-peer, and security. What tools are mainly used by this group? Stochastic analysis, and again, I'm not going to read through everything. You can see it for yourself. Simulation with internally developed tools. Optimization using standard and less standard techniques. Measurements, IP and TCP-oriented tools, characterization of network usage, and traffic classification. Actually, this is pretty interesting. And sometimes results of traffic classification are surprising. Anyway, experimental testbeds, live vehicular testbed, mesh networks, live monitoring of backbone networks. So let's move on to specific projects for this group as well. Video distribution over the internet, one of the biggest things happening right now. Video distribution applications have gained a central role in the internet, no doubt, with, I guess, several billion videos downloaded of YouTube every day. I think it's 3-4 billion videos every day. People involved are shown here. Content distribution solutions for the support of video distribution of the internet, caching strategies for efficient video support, peer-assisted systems for video distribution, and design of peer-to-peer TV applications are some of the main investigation areas in this topic. And there is a EU project, Napa Wine, active on it. Switching and interconnection networks. Network performance depends on the capabilities of the switching nodes and on the interconnection networks. And these people are concerned with the design of PC-based, meaning software routers, and storage and virtualization for disaster recovery. Sounds funny, but disasters happen, and you have to be able to recover from them quickly. And energy efficiency in switching architectures and networks on chips, an increasingly important topic these days. And there is a project, Sphingy, and no, these are not the Sphingy, but it's a project. Funny name. Anyway, wireless networks. Wireless access is crucial, but highly sensitive to interference and mobility. Spectrum resources are also scarce. These are the people involved in this study: vehicular and mobile, ad hoc networks, energy efficiency. Again, you'll see it repeated many, many, many times. Quality of service provisioning and cooperation. Again, cognitive radio networks, now seen in the realm of the networking layers. Sensor networks, proximity-based peer-to-peer technologies. These, again, are some of the several projects in which this is being carried out. Home networking. Now, federated, cooperative, I would say, residential networks, I would translate, can leverage neighbors' cooperation to optimize access network performance and costs. What does that mean? Home network management, monitoring, troubleshooting, content management for backup and caching. And this research is, coordination of neighborhood gateways for load balancing and energy saving again. And this is being carried out within the project Figaro and GateCom. And this is a URL on this. Optical networks overcome copper limitations in interconnections, reduce power requirements with respect to electronics. And these are the people involved, and some of the topics are microring, resonators, and integrated optics for all optical switching and routing, and WDM metro networks, and the project is strongest. So the Sphingy are also the strongest, same people. It makes sense. Andrea, don't take offense. I'm just trying to make it a little more lively. Traffic measurements. The actual behavior of the internet changes rapidly and is difficult to capture because of the network size and the variety of the applications. And so these people are studying traffic characterization and classification, passive measurement tools and techniques, and social network, very important these days, a lot of traffic on it, and infrastructure analysis. And these, again, are projects where this is being carried out. Energy efficiency and sustainability. Well, the energy consumed by the internet accounts for up to 10% of the worldwide total. So this is huge. And can we reduce it? And is the internet growth sustainable? Maybe at 10% is still okay, but if the internet grew to twice or thrice the size, could it go to 20 or 30%? No, that's unthinkable. So it has to go together with energy consumption reduction. So lots of people involved in this. So access network optimization in wireless and wired networks, as far as energy efficiency is concerned, green router and switch design, green routing and traffic engineering, and zero electricity networks. I don't know what that means, but it sounds really interesting. Go ask them, I'll do that. And sustainable networks. And there's several projects, Trend, Econet, Efficient, and so on. Laboratories, the networking group has laboratories as well, a wireless networks laboratory, Claudio Casetti, automotive networks, Guido Albertengo, Claudio Casetti, and so on, sensor networks, Guido Albertengo and Carla Chiasserini, and software routers, our Deputy Department Director, and live measurements, Marco Mellia and Maurizio Munafo. And to conclude, the overall telecom group is very active in cooperating with editorial bodies of the main journals in the field. And you see here a list of editors of international journals. Typically, people are editors, or associate editors, or one of two journals. But I think that Carla strikes here an incredible record. She's associate editor of 4 or something like that. I don't know, Carla, how you do it, because it's anyway. So this slide concludes my talk. I hope you're still all awake, and thank you very much for your kind attention.
Thank you, Pierluigi. We keep gaining time, so if we are going at this speed, we can add one additional poster session in the afternoon. I don't know if it's so easy to have questions on this type of presentation, but if there is anything that you want to ask, of course, you are free to do that now, or maybe later to contact Pierluigi, whatever you want.
Of course, whatever you ask, I could answer probably over a very limited part of what I showed you.
But you can ask help from the audience, you know. So. Okay, so thank you again.